Hello students, in this video we'll solve a calculus problem related to the intersection of two polar curves. In this problem I've plotted two polar curves, r equals 2, which is just this circle of radius 2. Looks a little bit elongated, but it's a circle of radius 2. It goes to the point 2, 0 and negative 2, 0. And then I have this elongated rose, or this propeller shape, r equals 2 plus the sine of 3 theta, and so you get this propeller shape, or this elongated flower shape. So the first thing we want to do is we want to find out, we're going to work in this problem exclusively in the first quadrant. So we're going to work in the first quadrant, so working in the first quadrant. These curves intersect at points, theta values, such that 2 is equal to 2 plus the sine of 3 theta. Well, the 2's will cancel, and that will just tell us that the sine of 3 theta is equal to 0, which tells me that theta is an integer multiple of pi, where here n is an integer, because the sine vanishes the integer multiples of pi. That tells me that 3 theta, of course, is equal to that, because I have the 3 theta inside the sine. And so the question becomes, which of these angles theta will correspond to angles in the first quadrant? Well, clearly, if n is equal to 0, theta equals 0 works. That's clearly a point where that propeller and that circle intersect. So theta equals 0 is one solution of this. And the next angle that will work, if I plug in n equals 1, I'll have a 3 theta is equal to pi, which will imply that theta is pi over 3. So between 0 and pi over 3 are the 2 points of intersection. Now we'll address the following question. So here's a question for us. Question: what is the arc length of the propeller? R equals 2 plus the sine of 3 theta. And when r is bigger than 2. So this is dashed line that I've plotted over here. So let's recall what the arc length formula is. The formula for arc length is going to be the integral from 0 to pi over 3 of the square root of r squared plus dr d theta quantity squared. And so what will that be? And of course this is going to be a d theta integral. So this will be the integral from 0 to pi over 3. And then what happens when I square this this curve r? I'll have a 4. I'll have a 4 from this. Then I'll have a total of how many? 4 sines of theta. So that's going to be a square root of 4 from this. Then what? Then I'm going to have a 4 times sine of 3 theta. 4 sine of 3 theta. And then I'll have a sine squared of 3 theta. So I'm going to have a sine squared of 3 theta, and then I'm going to have a what? I'm going to have to do the derivative, so let's find what dr d theta is for this problem. What's dr d theta? It's going to be what? It's going to be 3, and then what? 3, and then a cosine of 3 theta, 3 cosine 3 theta. Not a sine 3 cosine 3 theta. Okay, so the other terms we'll have over here, we'll also have a what? We will also have a sine squared 3 theta, and then also underneath the square root will be a what? Will be a plus 9 cosine squared of 3 theta. That's all under the square root d theta. Okay, so that is my arc length formula. And of course this integral cannot be evaluated. This is what's known as an elliptic integral over here. So this is an elliptic integral. And this elliptic integral cannot be evaluated in terms of elementary functions, so we just have to leave it in this form over here. Great. All right. Final question over here. Question: what is the slope of the tangent line to r equals 2 plus the sine of 3 theta at the point 2, 0, which corresponds to theta being equal to 0. Okay. Remember how this works. Since we have that y is r cosine theta, and r is a function of theta, so this is going to be f of theta, and likewise That's x actually, that's not y, so that's going to be an x. So x is r cosine theta. That's f of theta times cosine theta. And y is what? And y is going to be f of theta sine theta. Okay, so what's dy dx going to be? So dy dx is going to be what? Well, I'm going to do the derivative of y with respect to theta. That's going to be f prime of theta sine theta plus f of theta cosine theta over what? Well, the derivative of x, which is f prime of theta cosine theta, then minus f of theta sine theta. And so if we plug in theta equals 0 to this, so dy dx when theta is equal to 0, well, when theta is equal to 0, the sine's going to go away, and the sine's going to go away over here, and the cosine will be 1, so I'm going to have f of 0 over f prime of 0. Okay? So what is f of 0 over here? So f of 0, when I plug in 0, I have the sine of 0, which gives me 0, so f of 0 is going to be 2. And then what is the derivative of f, this thing over here, 3 cosine 3 theta. When I plug in 0 to that, I can get 3. So the slope of the tangent line at this point is what? Is 2/3. Thank you very much.